Hello all, we are going to start matrices from today onwards, and I'm going to introduce the matrices and how we use that one and operations on that. So let's dive in. Okay, what is a matrix? Okay, matrix is basically a rectangular array of numbers. So what it means, okay, 1 2 3 4. You can see this one has 2 rows. They are called rows, and then also it has some columns, so these are called columns. So you need to understand the columns and the rows, and then the order of a matrix. We call it order of a matrix. Let me get a different color. Order of a matrix is number of rows times the number of columns. That's how you write it. So that's called the order. And then the other one that we are going to look at is, if this matrix is called, let's say, A, what we are going to look at is first row, first column element. See the way, ladies and gents, I call the rows first and then the columns. So the first row, first column element can be represented using a lowercase a, 1, 1. First one mean the row number, the second value is the column number. In this case, it's 1. And let's have a look at the second value here. That's called an element. So you can see I have a matrix which is a rectangular array, like a rectangle or a square, as you call it. And every value inside is called an element. Now A11, what is this? A12. First row, second column element. That was here, wasn't it? Therefore 2. How about this one? A21. So what is this? Second row, first column. That's right there. 3. Then finally we have 2, 2. A22 means second row, second column element. In this case 4. Well, now we understand the rows and the columns and then the order and the elements. Well, what are the numbers I can put in this matrix? Think of, can I put just counting numbers 1, 2, 3, 4 or any other number? Well, this is the example. Now in this case, what I'm going to do is first define this as B, and I'm going to ask you, okay, what is B13? That is first row, third column element is this one, which is -9. As you can see, ladies and gents, this matrix has a negative value as an element. Therefore, you can have negative values, positives, fractions, even 0, just in here. Well, let me do this. B21. B21 is the second row, first column element. That is 3 on 7. It's a fraction, isn't it? Right. Now we understand the matrices. You know how to read the elements using rows and columns. Let's go ahead and use this one in our context of, let's say I have 3 cities A, B and C. What I'm going to show is, using these lines, the direct, let's say, roads between these 2 cities, 3 cities. In here I would have 2 and here I have 1. So what I'm going to do is now is to show this in a matrix. I have A, B, C cities and I have A, B, C cities. I am going to write down a number representing the number of roads connecting one city to the other. So it's from A to A, from A to B, from A to C. This is treated as from, and then here it's 2. So from 2. From A to A, there is no road. That's what I call a loop here. So a road like this. There is no road that goes out of the city A, comes back to it. We don't have it here. Therefore, we put a 0 for that particular value. In this case, I'm looking at first column, or rather first row here. Now, first column, from A to A, nothing. And also you can see B to B is also, there is no road. Therefore, I can put 0 there. 0 for C as well. Therefore, we can call in this case the diagonal. This is what I call the diagonal. Diagonal is with zeros. So the zeros are on the diagonal. Now let's look at the rest. A to B. A to B, there is only one road. Therefore, A to B, it's one road. As well as B to A, also one road. B to A. So it's one here. And A to C, that's one road. Same manner, C to A, one road. You can see these numbers repeat. And of course, this is what we call a symmetric matrix. This is 3 by 3, 3 columns and 3 rows, rather 3 rows and 3 columns. Now we are going to look at B to C. There are 2 rows, B to C 2 rows, C to B also 2 rows. Here we go. So we got the matrix representation for this context that connects the roads between 3 cities. So if in a question in 5B, if it asks you to do that, that's what you need to do, form the matrix. And then you can even interpret, what does this mean? That means the number of roads between B and C. So there are 2. So the number of roads between B and C, you can see there are 2 roads between B and C in that case. You can say there are 2 roads between B and C. That's basically representing the number of roads here. Right, hope you understood that one. Now let's have a quick look on how we actually put these matrices into the CAS calculator. You have to go to the main and then choose Math 2. So if you click there are 3 icons here. You can see one like a row, one like a column, one like a square. So you can, if it is 2 by 2, you can simply do that and then start entering values. Let's say I'm going to put 5 and then you go across 9 and then down and then into this one. Let's say negative 4 and then the other one is let's say 3. And then I'm going to press enter. It's just the matrix. Now let's say I want to simply assign this one to a variable, let's say A. So I need to assign this one to A. What I'm going to do is I'm going to copy this one and then can you see the arrow here? That's what you need to press. So you put that and then you go to the variables and you need the caps, let's say letter A, and then you execute. There you go. So that's simply added to A. Now if I press A and execute, you can see A is in fact that matrix. So in here you can save the matrix into variables and then we can use this one later in later calculations. We'll get back to that one. So this is simple introduction where you simply define a matrix and then assign values into it using the CAS calculator. I think that's it from me all. Now you can go and start the work plan on 5A and a B. Okay, happy learning. I'll catch you again in another video lesson. Thank you. Bye for now.